Okay, welcome back to Code Snippets. So here we're going to talk about some data types. So I'm going to create a new package here. So just right click, new package, and we're going to rename it data types because that's what we're talking about. So now we have a second package in here. Again, this is how you would sort of separate all of your different maybe assignments for a course. And then right click, new class. And then here we'll name it. I'm going to name it the same thing. It should let me. I'm going to click this checkbox. And great. So we have it all set up. So what is a data type? A data type is just a way that Java represents memory and information when you create a program. So for example, let's pull up Paint. When's the last time anyone worked in Paint? Okay, so we have really four main groups of primitive data types. We have numbers, which is over here. And then we have text. And then I'm just going to group these other two together. We'll call it other. And we'll make this full screen. Okay. So for our numbers, we have several types. We have ints, short, long, and then down here we have float and double. Okay. So what do all these mean? Well, int, short, and long, these are all integers. So what is an integer? An integer is just a positive or negative whole number. A whole number meaning it doesn't have a decimal point. So numbers such as 6 and 43 and negative 67 and 0, right? These are all integers. These can be represented by one of these data types, int, short, or long. Now, if they all represent the same thing, why do we have three different variables? Well, it's because they each store a different amount of data. So an int is a 32-bit variable, short is a 16-bit, and a long is a 64-bit. Now, it's not important that you know those exact values. All you need to know is that an int stores more data than a short, and a long stores more data than an int, sort of as the names imply. Now, for a float and a double, these two are in their own group because they store an integer plus a decimal point. Right. Overlapping a little bit. So they store an integer and a decimal point. So numbers such as 6.2 and 43.0 and negative 67.99436 and 0.1. So all of these would fit under the umbrella of either a float or a double. So float, again, this goes back to why do we have two of them. It's for the same reason that we have three of these. It's just different, a different number of basically bits that we're using. So a float is a 32-bit variable and a double is a 64-bit. So where do they get their names from? Well, float is referring to a floating point number. A floating point number is anything with an integer and a decimal. And then a double stores double the amount of data, hence the name double. Okay, text. We have two variables that fall under this umbrella. We have a char, and we have, I'll move it down a little bit, a string. So, what are the differences between these? It's kind of, it's a little bit related to how much data they store, but not in the sense that these are. Char and string store different kinds of text, quote unquote. So here's what I mean by that. A char stores one letter at a time, such as a capital A, a lowercase b, the number 4, and we'll say the $sign. Right? And then a string stores multiple chars, right? A char can only store one of these symbols at a time. And now keep in mind, so char is short for character, and a character is any symbol that your computer can display or store or use. So if you open up like a Word document using Notepad or something like that, and you'll see a bunch of random garbage letters, and those are all characters technically. So anything that's found in the ASCII table or the ASCII table, anything on the table can be represented by a char or a string. A string is just multiple chars put together. So for example, ABC, or 1, 2, 3, or a bunch of these, or any combination, such as A1, B2, oops, yeah, that's fine, B2, C3, that's all fine and dandy. It can also store just a single character, or it can store something called the empty string. So what's going on here? All right. So how do we differentiate between a char that stores a capital A and a string that stores a capital A? Well, it's with these single and double quotes here. So a single quote means we're talking about a char, but a double quote means we're talking about a string. And it's easy to remember because if we have a double quotes, that means it can store more information, right? It can store more than just a letter A, but in this case it is only just storing an A. Then we have this empty string here. What is that? So you can kind of relate the empty string to the number 0, where there's something there, right? It has a value, just like 0 is a value, but it represents that, like in the real world, you know, if you have 0 apples, you don't have any apples. If you have an empty string, you don't have any text. But it's not nothingness, because there is something there that you can work with. You can have 0 plus 1, right? 0 plus 1 is 1. You can have an empty string plus the letter A. That just gives you the letter A. This is not to be confused with our last group. And the first part is null. So null means the absence of data. It literally means there's nothing there. You can't really do anything with null. It's sort of just a placeholder value. So, for example, if you said null plus 1, that doesn't work. It doesn't make sense. It's just an idea, in a sense. It's almost like infinity. Like if you say infinity plus 1, again, that doesn't make sense. It's just an idea. And then our other is Boolean. So Boolean is just true and false. Pretty straightforward. These are both the values. So you can have the value true and the value false. That's really it. Pretty self-explanatory. So this empty string, even though there's nothing there, quote unquote, there's still a value, unlike null. Same with 0. 0 is not null because 0 actually has physically something there. You can see there's a 0. Okay, so this is the basis of our primitive data types. And if you notice, all of these data types have a lowercase letter, right? Except for one. And that one happens to be string. So string is our odd one out here. Because technically, string is not a primitive data type. And you're probably wondering, well, what even is a primitive data type? And basically, a primitive data type just means that it's the most basic unit of value, essentially. So you can't break down the number 10 any smaller than just being the number 10. Just like you can't break down true or false. Like true is just, that's the most basic it gets. Whereas a string is actually made up of chars. Like I said before, it's multiple chars put together. So You can break down a string and um, into smaller subunits, which makes it non-primitive. However, the way that Java was developed allows string to be used as though it is a primitive data type, because the developers knew that string was so important that it should be accessed the same way all the other primitives are, just because it's a lot easier to do so. So that's why string is typically grouped in with the rest of the primitive data types. Alright, so that's it for the basics of data types. And in the next video, we're going to talk about how to use those data types to declare and initialize variables, and what it means to use a variable.